Assalamu alaikum, dear students. Hopefully you are doing all good and you are well and fine. So dear students, as we are already done with our chapter number 1, we are done with this chapter completely. In this chapter, actually, we studied all the concepts relevant to an operating system. We studied about its purposes, we studied about its types based on its functionalities. We studied about processes, we studied about threads, we studied their differences, we studied the complete life cycle of a process from its beginning till its termination. We studied the functions of an operating system. So we are completely done with the concepts of an operating system. So moving forward, today in this class, we would be starting our new chapter, that is chapter number 2. This chapter is completely different from chapter number 1. This chapter is all about the development steps or development phases of a system, of a software. This chapter actually revolves around that, how basically a software project is developed, how a software is developed. There are certain steps or phases which are basically involved in the development of a software, of a system. But before going towards those steps or phases, there are certain concepts which we actually need to know, and those concepts are that first of all, we need to know that what is basically a system development life cycle, or we can also say that a software development life cycle. We need to know some major concepts relevant to that. It's some, you can say that introductory concepts. So secondly, we need to know is that what is basically the importance of a system development life cycle. Why we use a life cycle, a specific life cycle, in order to develop a system, in order to develop a software. What is the importance of using all those phases or steps involved in a life cycle, in a system development life cycle? What is the importance of those phases or steps? So the third thing which actually we should be knowing is that what are the specific objectives, what we would get by applying those steps or phases, what we would get out of that system development life cycle if we implement that life cycle in order to establish or develop a system or software. Then another very important concept is that we study about the concepts like phases or importance or objectives, but there are certain people who are directly or indirectly actually they are involved in that development life cycle. They are throughout involved in those steps or phases, either directly, either indirectly. So those people are the stakeholders. So we need to know about the stakeholders of a system development life cycle. So today what we are going to study is basically we would study the introduction of system development life cycle. We would study the importance of SDLC. We would study the objectives of system development life cycle. In short form, you can say, you can term it as SDLC. And we would lastly talk about the stakeholders of a system development life cycle. So the story starts from this major point that, okay, we would talk about what is a system development life cycle, but first of all, we need to know that what is basically a system. So a system is an organized collection of parts, or system is an organized collection of parts or subparts that are highly integrated to accomplish an overall goal. Means you can say that a system is something which actually consists of certain parts or subparts, and those parts are basically interrelated, or connected with one another. That's why we can say that the interconnection or the interrelation of those connected subparts or parts is called as a system. A system is a set of components. We can say that those components can be hardware or software, or they can include people, etc. So a system is a set of components, either hardware or software, for collecting, creating, storing, processing and distributing information. The system has various inputs. System actually takes inputs, and as a result it gives some kind of output. So the system has various inputs which go through certain processes to produce certain outputs, which together accomplish the overall desired goal for the system. So a system can be developed by applying a set of methods, procedures and routines in a proper sequence to carry out some specific task. So a system is usually made up of many smaller systems or subsystems. Now here, in order to make you understand this concept, I'll give you an example of an organization. Suppose an organization is made up of many administrative and management functions and products and services and groups and individuals. If one part of the system is changed, the nature of the overall system is changed as well. Now you need to take, or you can take the example of, let's suppose, our college's system. You can say that our college is an organization. So we can say that this is an organization, or system is actually running in this organization. A system is continuously running in this organization, and there are administrative bodies, there are certain departments. So this system or this educational organization is performing certain functions, and it's you can say that the education this system or this organization is providing, that education is basically its product. This organization is basically actually providing educational services to certain stakeholders. Like, I'm talking about students. They are the stakeholders who are getting actually the benefits of these services. But certain other stakeholders are also involved, like the faculty, the administrative staff, the admin staff, etc. They are all actually facilitating the product. They are all facilitating the services actually being given by the system, being offered by the system. So this organizational system is basically actually consisting of certain components. Now these components involved the tangible things like furniture, building and stuff, and as well as intangible stuff like services being offered by the teachers, by the admin staff, by the faculty, etc., etc. This system is continuously taking the input from students to the input from the faculty, the input from certain other bodies, and on the basis of that input, the system is generating the output, and the output is, the input involves the services too, and the output involves the services too. This system is using certain set of rules, set of methods, procedures and routines in a sequence in order to carry out specific tasks. And likewise, we can say that if one part of the system is changed, the nature of the overall system gets changed too. If one person gets replaced with some other person, it does not changes the overall procedures, but somehow it changes at that specific moment. It somehow interrupts the routine. Over and over, we can say that that a system is an organized collection of parts or subparts, and those parts are always integrated with one another to accomplish certain overall tasks. So here I mean to say that this system consists of components like building, furniture, individuals like faculty, administrative staff, students, and these all components are basically either tangible components, either intangible components. These are all components are basically integrated, or they are interrelated, they are in connection with one another. Now moving towards our basic concept, and that is system development life cycle. Now you need to concentrate here that what is a system development life cycle. The software or system development life cycle is the entire process of formal, logical steps taken to develop a software product. This means that this software or system development life cycle has certain logical or formal steps involved in it. You can say that planning. You cannot touch planning. Planning is a creative process which is controlled by your mind. Your creativity processes are always controlled by your mind. So we can say that planning is basically a step or phase of system development or software development life cycle, and this planning phase is a logical or formal step because it is being carried out by your mind, and mind actually is affiliated with logic, with creativity. So the software development life cycle refers to a methodology with clearly defined processes, with clearly defined steps or phases for creating a high quality software, a high quality system. In detail, the system development life cycle methodology is a systematic process for building a software or system that ensures the quality and correctness of the software built. That is very simple. Even in your real life, in order to get something done in your routine life, why you perform certain processes or steps in a sequence? Because you want to get that thing done properly. For example, let's suppose if you want to cook some dish, there are certain steps you have to perform in a sequence. So the sequence of steps is very important in a life cycle in order to maintain its quality and correctness. So the system development life cycle process aims to produce high quality software that meets customer expectations. Another very important thing is that a customer organization or an individual customer always places an order to some software development organization that I want certain type of system or software, kindly develop that system or software for me. You know, a customer is like a common person. He's not a computer science graduate, so he cannot develop a system for himself. So in order to get that system or software developed, he needs to go to some software house, to some software developer, to some software development organization. So that software development organization follows certain steps of the software or system development life cycle in order to produce or develop that system or software for the customer. So the major aim of that software team or software development team would be to actually satisfy the need of that customer who actually placed the order for that software or system development. So the system development should be complete in the predefined time frame and cost. System development life cycle ensures that the system or software which they are developing for the customer would be completed or would get completed in a scheduled time frame or in a time frame allotted by the customer. If a customer wants to actually get a software or system ready within 6 months, the software development team has to do that for that customer if they have that capacity and within that budget allotted by that customer. So SDLC consists of a detailed plan which explains how to build, plan and maintain specific software. software development life cycle is actually it actually consists of certain steps or phases which actually tell that software development team that how to plan, how to build, or how to maintain that specific software. The usage or the advantage of that those steps or phases is basically that they maintain the order of that software or system being developed, starting from the defining or planning stage till the maintenance stage. So every phase of the SDLC life cycle has its own process. Means if suppose there are 9 to 10 steps or phases involved in software development life cycle, each and every phase, each and every step would have its own processes. Means in planning stage, something else is being done, some other processes are under observation, some other processes are being performed in coding stage, some other processes are being performed by some other person. In testing stage, some other processes are being carried out. So each and every step, each and every phase has its own certain processes, and at the end of that specific phase, at the completion of that step or phase, that step or phase would deliver something. Planning stage is there to deliver something. Defining stage or defining phase is there in SDLC life cycle to deliver something. Feasibility phase is there to actually deliver something. So each and every step or each and every process, each and every phase of the life cycle has its own affiliated processes, and each and every step or each and every phase would at its completion, it would deliver something, some deliverable. That is called as deliverable. That thing which would be delivered at the end of each phase or step, that would be called as a deliverable. We would inshallah talk about these deliverables and each about the processes and steps one by one after that. So the phrase system life cycle simply describes the steps that are taken in a project from the time that the project is started to when it is finished. When a software development organization actually takes that development process in its hands, we can say that that software development organization is basically starting a project. They take it as a project when they start the process of developing, or they start the process of working on that software or system. We say that they have started a project. You can say that software development team or software development organization is actually fulfilling, or they are taking the project of creating a system or software. So project always has a start and a project always has an end. A project can be of any type, but in software industry, we can say that that system or software can be developed using certain steps or phases involved in a system development life cycle. So when any computer related project is initiated, a number of distinct steps or stages can be identified in the life of a project. So each of these stages will involve people doing jobs and producing things. These producing things is actually called as a deliverable, D-E-L-I-V-E-R-A-B-L-E. So every step would generate something, every step would produce something. That thing would be called as a deliverable. For example, in a designed document, or a test plan, or a piece of program code in coding stage or coding phase. So each of these things take the project a little further towards the completion. Every step or every phase of system development life cycle actually adds some value to that project. Things that have to be produced at the end of each stage are known as deliverables. You need to understand that things that have to be produced at the end of each stage are known as deliverables. In software engineering, there are certain models and like waterfall model, agile model, iterative models. So each and every model has different number of steps or phases involved in that. Some models have, in software engineering, some models have 5 steps to develop a software. In some models, they have 7 steps for developing a software or system. So it varies according to the model. Here we are not going to talk about the model, just simply we can say that a system or software development lifecycle actually here has 10 steps involved in it. First step is basically defining phase. In this defining phase, it would be defined by the system development team or software project management team that what is basically the basic problem, what is the problem statement. They would identify that what actually they would need to develop. They would take the requirements from the customer, that what does that customer want. Either customer wants to have a brand new system or software from scratch, or the customer wants an existing system or software to be upgraded by that software development team. So they would definitely define the problem. They would identify the problem, that what actually they need to do, what they actually need to develop. They would understand, they would try to understand that problem. While in planning stage, after they would have understood, they would have understand the problem or problem statement, or the requirement of the customer, that actually what customer wants. They would afterwards, the project manager and the system analyst and other members of the team, they would plan the project. Basically, a project manager plans the project. He's a major person who is actually handing all other people to, actually who are over the team. So in this planning stage, certain things would be planned. Of course, when we want to start something, when we want to start study, when we want to start ourselves for exams, when we want to do something, when we want to start something, we always plan that. Before doing something, we always plan that thing, either on paper, in our minds. Here, proper planning would be done on paper. Resources would be planned, that what resources would be used. Personnel or team members who would be involved with that software steps, that would be decided. The cost or budget would be planned, that which step or process would take, how much cost, or how the expenses would be managed, stuff like that. So many things are planned in this phase or step or stage. In third stage, feasibility stage, after planning resources, after planning each and everything, the feasibility study of that planned or proposed plan would be actually estimated, that would it be feasible for the organization to do that proposed project or not. But basically, the strengths and weaknesses of that proposed or planned project would be analyzed. The strengths and weaknesses would be highlighted, that what are the strengths and what are the weaknesses of this proposed planned project. While in analysis phase, some other certain aspects of the project would be analyzed by interviewing and by observations, by analyzing the market trends of that sort of project. In requirement engineering phase, requirements would be gathered, either functional requirements, non-functional requirements, all the requirements which were actually planned in the planning stage, either hardware requirements, software requirements, any sort of requirements. These all requirements would be actually made available or would be purchased by that software development team in order to get their work done, in order to start working on the project. In the designing stage, now the process of designing a project or a software or system would be started completely. So in design stage, now the layout or the front end and the back end, etc., these sort of things are designed by any team member, by a software architect, or etc., etc. In the coding stage, now that designed software has been applied properly through the use of some high-level languages, proper back-end coding is now being done by the developer, by the programmer, by the software engineer. After the coding is done, now the in which algorithms and proper coding is involved. After the coding stage is done, now that coding or that prototype is actually tested by some tester. After the testing becomes successful, the errors are removed. The errors which are actually part of the coding, those errors are removed. Then afterwards, the team members would assume, the project manager would assume that if testing gets successful, now the software is ready. So they would afterwards deploy or install that system on customers' computers or inside customers' organization. And after deployment, if some issues come along the way, so the maintenance team would further actually, over the passage of time or with the time by time, they would actually become available for the maintenance of that developed software. So the idea behind the project lifecycle is that the deliverables associated with each stage in the project must be produced and checked off by the project manager. As told you earlier, that each and every step or each and every phase of system development life cycle actually produces some deliverable. So each and every deliverable is actually checked by the project manager, who is the project manager of overall that system development life cycle. So a stage cannot be started, another phase or step cannot be started until the previous stage, until the previous step or phase is finished. This stops a project getting ahead of itself. If the defining phase is not done, the project manager would not allow the team members to start the planning stage. If the planning stage is not done, the feasibility stage is not started. If the feasibility stage is not done successfully, the analysis stage would stage or phase would not get started. For example, it will stop something trying to start the stage called implementation stage before all of the design, development and testing of the prototype has been done. So you may have had some experience of this scenario yourselves with your class, as you cannot move on to the university level if you have not completed your FSC. Your education is actually a step-by-step process. You cannot go to metric if you have not passed 9th class. You cannot go to 9th class if you have not passed 8th class. So your classes, like your education, a system development life cycle is also a stepwise process. If the previous stage is not done successfully, you cannot actually opt for the next stage. You may have now got my point, what I want to say. So this, however, is the road to potential disaster if you go to metric directly from 8th class skipping 9th class. So for example, how can a project be designed if it is not clear what the problem is? You need to know certain things about these steps, that if the problem statement is not identified in the defining stage, the other step designed, like you can say that design phase, the project manager or the team members cannot move on to the design phase. So how can a project be built if it is not designed, if the problem statement is not identified? So how can a software be installed if it is not properly tested? Means installation phase or the deployment phase comes before the maintenance stage, but it comes after the testing stage. If the software coding or if the software has not been successfully tested, its after stage means the deployment or installation phase cannot be performed. If the software has not been successfully tested, the software cannot be deployed or installed in the customer's organization. Likewise, how can a project manager accurately manage a project if they can't clearly see that deliverables are being completed on time and within the budget? A project management cannot accurately manage a project if he can't see that each and every phase deliverables are not being delivered on time or within budget. So each and everything needs to get monitored by the project management or by the project manager very clearly. How can someone make changes to the product in the future if the documentation is incomplete? Means if the documentation in the planning or the feasibility stage, if they are not completed, if they are incomplete, likewise in future, in maintenance stage, the maintenance cannot done or the upgradation of that software in the future cannot be done if the documentation is incomplete or if the documentation is missing. Now coming towards after the introduction of SDLC, we would now talk about the importance of system development lifecycle. The basic purpose of system development lifecycle is to develop a system in a systematic, in a sequenced way, in the perfect manner. Here are the prime reasons why software development lifecycle is important for developing a software system. Number one, software development lifecycle is important because it offers a basis for project planning. Scheduling means making schedules or timetables for completion of certain steps or phases or activities. It also offers estimation of budget or cost. Now, a very important thing you can understand it is that the importance of system development lifecycle is that it offers planning processes, it offers scheduling processes, it offers the estimation of budget and cost. Number two, it provides a proper framework based on certain steps or phases for a standard set of activities and deliverables. This SDLC lifecycle properly tells you that how to perform certain activities in a sequence and how each and every step or phase would produce certain deliverable. Another very important concept affiliated with SDLC is that it is a mechanism for project tracking and control. That is an excellent feature of SDLC, that it provides the project manager with the facility of project tracking. Means the project manager can track each and every step. He can track the deliverables, he can track the processes, he can track the activities being carried out in each and every step or phase of SDLC. He can track the performance of a software development team member. He can track the work done. He can track that how much work has been done in a certain step or phase. He can estimate, he can track that the defining phase is done, the planning phase is done, okay, the feasibility stage is in process, and how much work or processes have been done in the feasibility phase or stage. Likewise, many other examples. So another importance of system development lifecycle is that it increases the visibility of project planning to all involved stakeholders of the development in the development process. Here the visibility means that the process of creating or developing a system or software is very transparent if a proper software development life cycle is being used. Means stakeholders like team members, stakeholders like customer, they get to know with each and every step or phase that that how much work is done. Means if the feasibility stage is done, if the analysis stage is done, the customer can see, the project manager can see that okay, these steps or phases are done, and these steps or phases are remaining. Means this much work is done, and this much work is remaining. So the visibility is there. They can track and they can monitor the work done. They can track the progress. So another importance is that it provides SDLC provides increased and enhanced development speed. I would say that these steps or phases actually add a value to system development life cycle, because it is very easy for team members to get divided as per the phases or steps. Each and every team member would be engaged with a certain step or phase, and they would know that this process or this step or this phase is done. Then after that phase, another phase would start. So they are very clear that one stage or one phase would get completed, then after that another stage or phase would start, and with each and every stage or phase, certain team members are engaged. Certain team members are engaged with planning, certain team members are engaged with requirement engineering, certain team members are engaged with the feasibility study. So this speeds up the development speed of that software or system. It also improves the client and team members' relationships. Visibility is the most important thing which actually develops the trust of a client. All the steps are so visible, or the tracking of the progress or monitoring of the project is being done by the project manager. So at any time, the client or the customer organization can contact the project manager, and they get to know that how much progress has been done, how much work has been done. So it improves the customer or client or relationships with the software development organization. Another importance is that it helps you to decrease project risk and project management plan overhead. Means as all the steps or phases are in sequence, all the steps are clearly defined, proper team members are actually attached or involved with certain steps or phases, and all the activities are very clear, they are in sequence. So this decreases the project risk. All the people are doing work in a sequence. The software development life cycle is going in a sequence. This decreases the project risk. When things are organized and in a sequence, this actually decreases the project risk. SDLC delivers quality software which meets the system requirements. Means this life cycle or these steps actually ensure high level quality of the software, because each and every step would produce a deliverable. Each and every step would be checked by the project manager one by the other. The project manager would check all the processes being done by the team members in each and every phase of the SDLC. He would check the deliverable. He would check the quality of deliverable being produced by each and every step or phase of the SDLC. So that would surely increase the quality of the software system being developed. So SDLC also ensures that the requirements for the development of the software system are well defined and subsequently satisfied. Means it also takes care of the requirements. Those requirements, either hardware requirements, either software requirements, either staff requirements, human resource, like what type of staff members or staff or experts are required for certain phase. So this ensures each and every type of requirement, either hardware, software, which are actually required during the development of that software. SDLC delivers cost-effective system. Means this life cycle, the phases or steps involved in this life cycle would actually enhance the productivity, and these steps would make sure that the software gets developed in the allotted budget, as each and every step would assure that work or the deliverable should be produced on time, so that would actually be effective in terms of cost. So SDLC also maximizes the productivity. That is very easy. That would be very easy for each and every team member to work in a fixed or in a separate phase or step, and be focused on just one activity actually allotted or assigned by the project manager relevant to that specific step or phase of SDLC. Another importance of SDLC is that it increases the visibility, as talked earlier, and it decreases the project risk. So without using an exact life cycle model for software or system development, the development of a software product would not be in a systematic and disciplined manner. You can relate it to your daily life. If you are not doing something, you are not performing a task in a disciplined way, in a systematic way, you would notice that activity or that task actually messes up. It consumes your time more than usual. So sequenced steps, the tasks which you actually perform in a sequence, these type of tasks consume less time. So when a team is developing a software product, there must be a clear understanding among team members or team representatives about when and what to do in which phase or state. So otherwise it would point to chaos and project failure if the sequence of activities has not been properly described before the development of a software or system. So this problem can be defined by using an example. Suppose a software development issue is divided into various parts, and the parts are assigned to the team members. From then on, suppose the project manager or the team representative is allowed the freedom to develop the roles assigned to them in whatever way the team members like. So it is possible that one team member might start writing the code for a software. Another team member might choose to prepare the documents first. Some other team member would begin with the design phase of the software development lifecycle. So when there would be no sequence or no systematic steps or phases performed or adopted by the software development team, when there are no systematic or sequenced steps, then each and every team member would start from the stage or phase of his own choice. So a software lifecycle actually eliminates these sort of things. If some team members are practicing this kind of stuff, this would be one of the perfect methods for project failure if those team members are not performing the software development steps in a sequence. What I was saying, that a software lifecycle model describes entry and exit criteria for each phase. A phase can begin only if its stage entry criteria has been fulfilled. So without a software lifecycle model, the entry and exit criteria for a stage cannot be recognized. So without software lifecycle methods, it becomes tough for software project managers to monitor the progress of the project too. Now, after the importance of SDLC, now we would discuss the objectives of SDLC. A system development lifecycle has certain primary objectives, which are that SDLC ensures that high quality systems are delivered, which actually meet the customer requirements and needs with best features, best interface, user-friendly interface, easy to maintain and handle operations of that software or system, and that system should be reliable. So another objective of SDLC is that it provides strong management controls over the projects. Means It establishes an appropriate level of strong management authority to direct, coordinate, control, review, and approve the software or system development project. Another objective is that it maximizes the productivity, means productivity of the customer, means it helps customers to get his work done. It is beneficial for the customer's organization in day-to-day routine, helps tasks done on time. So the software development lifecycle maximizes the productivity of each and every stakeholder, each and every team member involved in that software or system development project. Another objective is that it identifies the potential project risks in advance, so that proper planning should be done in early to work efficiently with the existing and planned infrastructure. Another objective is that it lowers the cost of development, means it is cost-effective system. So you can see that certain objectives or importance of SDLC are actually matching. You can adjust certain points if certain points are matching. So till this moment we are done with the introduction of system development lifecycle. We are done with the importance of system development lifecycle. We are done with the objectives of system development lifecycle. Now moving on towards the last topic of this lecture, and that is stakeholders of system development lifecycle. So stakeholders of SDLC are those entities, those groups, those people which get affected by that system, by that project, or they are affecting that project or system. So we can say that a stakeholder is a person who's directly or indirectly getting affected by the system, or is actually that person is affecting the system, who's directly or indirectly related with that project. Project manager, who overall manages all the personnel, staff, or plans, or manages the activities being performed relevant to a project. So we say that project manager is a stakeholder because he is affiliated with that system development lifecycle or software development lifecycle or system development project. He is involved with that project as a project manager. He is managing the certain activities. Suppose a sponsor who funds the project, or who a sponsor or a customer who actually has placed the order for that software, for that system. He wants to get that system development for his organization. So that sponsor or customer who's giving the budget to that software project team in order to develop that software or system, so that customer or sponsor is also a stakeholder because he is actually getting that system or software developed for his organization, for himself. Likewise, a system analyst who takes customers' requirements, notes them down, analyzes those requirements, analyzes the project proposal, analyzes the feasibility. So that system analyst is also a stakeholder because he is part of software project management team or software development or system development team. Likewise, a system architect who designs the system or software, he's also a stakeholder. A developer, a programmer, software engineer who performs the coding or programming or development of that software or system, he's also a stakeholder. A tester who tests the software after its development, after its coding. So that tester who tests the software for bugs, he is also a stakeholder. A user who finally uses the developed software, actually he is also a stakeholder. The end user is also a stakeholder. So the stakeholders may be users, managers, or developers. So the operational or deployment team who deploys or implements or installs the system or software after development into the customer's organization. So that operational or deployment team members are also stakeholders. Likewise, production support team which performs maintenance of the deployed or installed system. It is the duty of the project management team to identify the stakeholders determine their requirements, expectations, and manage their influence in relation to the requirements to ensure a successful project. You can analyze that some of the stakeholders actually are inside the organization. They actually belong to that software development organization, so we call them as inside the organization stakeholders, or within the organization stakeholders, or internal stakeholders who are actually originally part of the system development or software development house or software development organization. So we can say that some stakeholders are within the organization, some are outside the developing organization. So the entities which belong to that organization, software development or system development organization, they are called as internal stakeholders, while the end user or the sponsor or customer, these are also stakeholders, but they are not part of the software development organization. So they are outside the organization, so that's why they are called as external stakeholders, or outside of the organization stakeholders. Like if you talk about our institution, our organization, from a watchman to administrative staff to clerical staff, or to clerical staff, or to establishment branch, to exam cell, to the faculty, to students, all of them are actually stakeholders of this institution, of this organization, because they are getting affected by this organization. They are getting the services, or they are providing the services, or affecting the system. So dear students, this is the end of our today's lecture. This was our first lecture of chapter number 2. Hopefully you have got or grasped the basic idea that what is basically a system development life cycle, what is its importance, what are its major objectives, and what are the stakeholders concerned with that system, or who are involved with that system development life cycle. Inshallah, in our first lecture we would be we would be studying extensively the steps involved in system development life cycle. We would, inshallah, from next lecture onwards, we would properly actually start the steps or phases of system development life cycle. Till then, take care of yourself and stay healthy, and inshallah we'll continue this lecture. Allah Hafiz.